Hi. Good morning and good afternoon, depending on where you're dialing in from today. My name is Shanika, and Thiago and I, who are software engineers in the Cloud Spanner client libraries and developer experience team, will be presenting to you on how to get started with Cloud Spanner client libraries and ORMs today. So these are some of the topics that we're hoping to cover today. We're going to go into a little bit of details about client libraries and specifically some interesting concepts that like sessions and how to configure some client library options. We'll talk to you about some introspection, metrics related to client libraries, and we'll also go through some drivers and ORMs that are available that you could use Cloud Spanner through. Great, so we'll get started with client libraries. So what are client libraries? So essentially they enable user applications to use Cloud Spanner as a database. So I've tried to sort of have a diagram of what this kind of looks like. So from the client side, you have a client application, and in that you can import the Spanner client library in different languages. And this Spanner client library is really a kind of an abstraction over the gRPC client, which is kind of the client side of the server that will kind of serve your requests from the Spanner server side. So on the server side, once you send a request over, it will go through the GFEs, which are kind of the Google load balancers that will route your request to the right place, which will kind of reach your like the Spanner front ends, which will then forward them onto the Spanner backend for serving the actual request. Great. So why would we use client libraries? So client libraries allow you to kind of make programmatic use of Cloud Spanner through client applications. And it's also makes it kind of, provides like an idiomatic way to access, use Cloud Spanner through a given programming language that your application might be written in. And sometimes you may not necessarily want to use Cloud Spanner through an application, but you might just have, some scripts for, creating and updating databases, and it might be kind of good to, you may not be doing this repetitively all the time, but you may want to have these scripts written down to kind of run if you need to recreate your databases, and using the client libraries to do that, it might be a good idea. One of the main reasons that the client libraries exist is to also kind of provide some sane defaults. And we're going to be talking about some of the parameters that could be set in the clients, and also for doing session management, which I will cover shortly. All right, so why would you not use the client library? So there are some alternatives. One of them is the REST API. You could, potentially use the REST API directly through customer applications. One downside of this may be that the gRPC clients are kind of more optimized for sort of the wire transfer. And the REST API may not be, so it might just, for kind of the most efficient way of using Cloud Spanner through an application, it may make more sense to use the client libraries. There's also gcloud, which is a command line interface to manage instances and databases to and to run queries. And there's also the Cloud Console, which is the UI that we provide so that you can manage, instances and databases and also run queries. So for operations that you only need to do rarely, you can consider using gcloud or the Cloud Console. And, these might include, creating and managing instances, which is not something you'll be doing all the time. And maybe even for running, one-off queries to test how the query works and to see, an example set of results. Great. All right. So now that we know why we would use client library, so what languages is it available in? So we have it in 8 languages. So these are listed here. And all of these languages are in what we call a GA state. So it is fully supported by Google, and they have pretty much sort of like a very same set of features. There might be some slight differences based on what is possible in each language, but they ultimately are meant to be equivalent. All of these client libraries are open source, and we develop fully on GitHub, and we also welcome contributions from the community. So what's the best way to get started with using the client library? So I highly recommend taking a look at the Getting Started guides for each language that's available in the cloud documentation. Because it shows you how to do some common operations like, creating a database, inserting data, querying it, updating the data, and also using transactions, and also creating and using indexes. Okay, so these client libraries exist, and I've said that the client libraries are kind of like a wrapper around the gRPC client. So why did we write a wrapper around the gRPC client? This is because Cloud Spanner has a kind of an interesting and different concept compared to other databases, and it's called sessions. So sessions are the Spanner abstraction that allows users to run transactions. So you might know about database connections that are available in other databases, but these sessions are not the same as database connections, because the connections are really handled by the gRPC layer of the client library, and they're not the same as sessions. So now that we have these things called sessions, it can be quite complex to manage them, because every time you want to run a transaction, you want to create a session and then use it, and then you have to either keep it alive or delete it, because sessions do use up resources in the back end. So instead of making our users do this, we actually manage a session pool in each of the client libraries. So this is one of the main reason for the existence of these clients. Another interesting thing that clients do, excuse me, is retrying aborted transactions. So Cloud Spanner, just because of its sort of distributed nature and sort of the strict consistency guarantees that it gives, can also have a higher rate of aborted transactions. And in client applications, you may not want to handle these manually. So the client libraries themselves will catch the aborted transaction errors and will retry them to some extent with exponential backoff. So, okay, so now I've said we have this session pool in each of the clients, and they are configurable to some extent. So we have a few parameters. So these are based on the size of the session pool. So there's a minimum number of sessions, which means that the pool is initialized with at least this many sessions. It's max sessions, which tells you how big can the pool grow, like what is the maximum size, and the number of channels. So this concept I will introduce in a later slide. So what are the best practices? Given that these options exist, what should you do with it? I would say these options are available, but try not to modify the default configuration. And we cover what the defaults are in an upcoming slide. So the reason being that there are very kind of specific configurations that may work for each of the based on what's available in each of the languages. And if you need to modify them, there needs to be kind of a good reason as to why you would want to do that. And if you do need to modify them, I would follow the guidelines on the provided link. Another thing you could do if you really want to have your application have the maximum amount of sessions available to it at all times, so you can send, that many concurrent requests, then you can start off by saying, the minimum number of sessions is the same as the maximum. So that's an option to kind of, not have to pause to get the next lot of sessions if you run out of the minimum number of sessions. All right, so we also mentioned a concept called channel. So this may also be kind of new to you. So this is a concept in gRPC. So a gRPC channel is sort of a thing that maintains a TCP connection with sort of the Google load balancers. And why is this necessary? Because the way the clients are set up, the sessions have an affinity to a specific channel. So when we create a client, there's a certain number of channels that are available, and the sessions are kind of distributed evenly as possible across these channels. But we also want to try to keep the number of sessions per channel to less than 100, because if you get over that limit, then the GFE will start queuing the request and you may start noticing some latency. So, this is kind of one of the reasons why I said earlier, try not to touch the configuration, because, you have to kind of understand this idea to be able to configure it without kind of causing, your application any harm. So if you are configuring this parameter, so max sessions and num channels, try to make sure that, there's, less than 100 sessions per channel. Okay, so what are the defaults that we've specified for each of the languages? So the defaults are really very language specific, and this is based on what functionality is available in each language. So Java, Go, and C#, they kind of have bigger session pools. So you can, by default, you can go up to 100 sessions, and the number of channels is 4, but you can get up to, I actually forget the limits. So Thiago, you might have to tell me later. In Java, I think you have a maximum limit.
It's 256 channels.
There you go. Okay, 256 channels. So C++ has a very similar configuration. For Node, there are no channels, so I wouldn't recommend going above 100 sessions there. And I think the same goes for Python, and Python has different kinds of pool implementations, which you can read about in the docs. And Ruby also has no channels, and for PHP, this is a very interesting one, just because of the nature of how PHP, serves requests. You actually, so what you don't want to be doing is for every request creating a new instance of the client library and then creating a session pool from scratch. So what you need to do in PHP is to actually create a cached session pool that you can use over and over again. Cool. So there's one last concept about client libraries I want to cover, which is a write fraction. So in some languages, a portion of a session pool can be pre-prepared for doing read-write transactions. And this means that we've already called begin transaction at the time the session was created. Now, so the configurable sort of write fraction parameter determines the portion of the pool that's pre-prepared. So this is not actually available equivalently in all languages, because languages kind of try to optimize this. Some languages try to optimize this. So for example, Java and C++, there is no difference between whether a session is read or read-write. If it's a read-write transaction, it will inline the begin transaction call with the first statement. So there's no write fraction to configure. C# and PHP does have this concept, but it's managed internally, so it's not possible for you to configure that. Python has a transaction pinging pool, and that kind of ensures that the sessions are prepared already. And the remaining languages do have a write fraction, as linked to in this document here, and you can configure it to what you need it to be. So if you have a write heavy application, you might want to configure that. And the last thing I want to talk about before I hand off to Thiago is, what if you have a high QPS application? So essentially, this session pool that I've talked about, it sort of allows you to send, that many, I guess, as maximum number of concurrent requests to Cloud Spanner. And so if you want for this to be high, then you probably want to consider Java, Go, C# or C++ clients, just because you have the ability to create a larger session pool. But for languages like Python, Node, PHP, and Ruby, because there are limitations on how many sessions that you could create, you may need to kind of manage a multi-process application in order to get the same scale as some of the other languages. All right, with that, I will hand over to Thiago.
Thanks, Shani. Let me just present here. 1 second. Cool. Yeah, thanks, Shani, for introducing that. So we're going to talk a little bit now about introspection and how can you monitor your Spanner application. So as Shani mentioned before, we do have the client libraries. The client libraries connect to our load balancer, which is the GFE, and GFE routes the request back to Spanner. So we do have metrics and tracing across different layers of the architecture you're seeing here. So we do have metrics in the gRPC layer. We do have client-specific metrics, which are going to show in a bit. And for Spanner itself, we expose a lot of things so you can properly configure your Spanner instance, right? So we use open census and open telemetry to expose metrics and tracing. I think the most interesting metrics that you're going to see in the client libraries are session pool metrics, because they are such a core concept in the client libraries. We do have a couple of blog posts that highlight how you can tune your application based on the observed values of the metrics you see for Java and Go. Unfortunately, we don't have these metrics exposed in all the client libraries. So the most mature ones are Java and Go, and Python has OpenTelemetry tracing, but all the other ones, we're still waiting for OpenTelemetry to have a GA status before we add the specific metrics here. So as I mentioned before, the session pool is such a core concept that we want to make sure that you have full visibility on what's going on in the client libraries regarding that. So on the left here, you can see a graph about the session pool usage. On the top, you see the max number of sessions that are available to you. In this case, is 400. The middle line tells you about the max sessions that you used in a window period of 10 minutes. And the bottom line shows the number of sessions that are currently in use. So what's interesting about this graph is that if you see the bottom line, the in-use sessions, go up to the top line, the max allowed sessions, then it's a clear indicator that you're using all your concurrent sessions in the client library, and you might want to go and adjust your session pool size, right? The other graph that we see here on the right shows the number of acquired sessions versus the number of released sessions. So you basically see one line because both of them are being overlapped on top of each other. And that's good because we are acquiring sessions from the pool and we're releasing sessions to the pool so that they kind of match. If you see these lines drifting apart, it might mean that you have a problem in your application where you're just acquiring sessions and not releasing them. So it might be what we call a session pool leak, right? So that's also an indicative that you should take a look at your application and see what's going on. Next, we do have, several metrics and introspection tools for Spanner itself. So we do show, the CPU that you're using, the storage, the network, how the number of requests, the number of writes, the number of reads, and all of those metrics you can use to better size your Spanner node instance. We also have query plans. We have we have statistics tables in Spanner, which you can see how the logs are being used in your queries. You can see also the top queries in terms of execution time. So we do provide a lot of tools for you to take a look and better adjust the performance of your application. Cool. So with that, I just want to jump into some of the drivers and ORMs that we support other than the client libraries. I'm going to go a little bit fast here because I think we're running out of time. So excuse me, but we do have a driver in GA, which is JDBC. Its features include internal retries for aborted transactions, specific connection state SQL statements such as reading the read timestamp of your queries, the commit timestamp of your queries, and it supports DDL and DML batches. We do have for Java then Hibernate as an ORM. It only supports DML. It doesn't support mutations at the moment. We do have Spring Data, which supports both DML and mutations for Java. We're currently working on Django, which is in beta for Python. The GA release is coming soon. We do have Entity Framework for C#, and it supports DML and mutations very appropriately. It currently is in preview release, so not production ready, but we're coming close to GA soon. And finally, we have SQL Alchemy for Python, which is pending preview. It's not production ready yet, but it's another offering other than Django that we're working on. So with that, I just want to close that. All of our, as Shani mentioned, all of our projects are open source in GitHub. You can open an issue for any bugs, feature requests, or comments that you have. We are accepting contributions there. And we also have another organization called Cloud Spanner Ecosystem, where our passionate customers have open source tools which are useful for all the community that uses Spanner. So in that sense, we have some tools like Liquibase, which is a schema management tool for Java. We have scheduled backups for Spanner. We have a project called Harbor Bridge, which helps you analyze schema migration from MySQL to Spanner. And we are accepting contributions there, or if you have any ideas of any projects that you want to write for Spanner, we're glad to help and work with you. So that's what we had. Thanks a lot. And if you have any questions, we'll be happy to take them.
I see. Okay, cool. So just repeating the question, would you be able to provide insights into why the min-max session configuration values and limits differ by language? It's essentially due to the availability of channels is what limits it. So there's probably some work we can do to make it like completely consistent. So note that C++ had 0 min sessions, and we could easily make that to 100. But for languages like Node, where there is no concept of channels, we actually can't increase the maximum number of sessions to above 100 because of this this GFE parameter that we have to kind of follow. I hope that explains the differences.
Yeah, thanks.
Cool. Can you share the link to the slide? So I think we'll work with Roy to figure out how we can share the slides. Okay, so this is a good question. So if GFE start to apply back pressure, is there some way we can detect that through metrics? I'm actually not sure about the answer to that. So if anyone else in the call knows, please chime in.
Yeah, I think one thing that you're going to see is that we also are going to borrow the sessions, and from the session pool, we start executing it, and we don't release them, right? So you're going to see the number of borrowed sessions in the metrics that I shown before here. Let me go back. Here, sorry. So the number of in-use sessions kind of top and go to your max here, which is one indicative that there might be a problem. But the other thing that Shani mentioned, which is very important, is that you don't use more than 100 sessions per channel, right? In terms of the Hibernate, I guess it's just if you're already using that for other like connecting to other databases, then it's kind of a clear and familiar framework for you, so you can use that. That's our idea here. We want to provide a good developer experience for our cloud spanner customers. In terms of advantages, I don't see any advantages other than the modeling of your application or the design of your application meeting your already existing frameworks and tools. Yeah, one thing that maybe we can highlight again is that if you're building an application and you're looking for performance, our most mature clients are the Java and Go lang ones. So that's where you're going to find the most optimizations that we've done and the most configuration options and such. Thank you.
Great. Thank you, everyone.
Oh, one more.
Yep, cool. Could you speak a bit about the client timeouts? If we have an app that needs to serve each request within 1 second or else fail a request, it's not worth having the Spanner client spend more than 1 second on an inquiry. Is there a way to manage timeouts on the Spanner client? Yes, there are the custom timeouts and retry configurations that you can set in each of the client libraries. So we can I'm not sure exactly how to share this, but we do have some documentation on the public Cloud Spanner documentation site. So if you search for custom timeouts and retries for Cloud Spanner, I think you should be able to find some code samples that show you how to do that.
Specifically for Java, you can even configure have different retry settings and timeouts for each RPC call, which is very interesting if your application needs that dynamic configuration. So, but setting up and configuring timeout is a core concept in gRPC, and that's something we borrow and use in the client libraries.
Great.
Cool.
Thank you, everyone. Thanks for coming in and also for all the great questions as well. Hope you all have a nice day.
Thank you.
Thank you very much.
Thank you, Shani. Thank you, Thiago. I'll end the recording now.
Thanks.